Welcome to this special edition of the New Stack Makers on the road for KubeCon EU 2022 in Valencia, Spain. Discussions from the show floor with technologists giving you the expertise and insights that will help you in your everyday work.
Hi, it's B. Cameron Gain, correspondent today with the New Stack. I'm here today at KubeCon CloudNativeCon 2022 in beautiful and sunny Valencia, Spain. I'm here today to talk about Wasm, or WebAssembly, and some of the implications and usages, and more specifically, what it is and how it can solve certain business needs, which I feel are often overlooked. And I'm here today with Colin Murphy of Adobe. Hi, Colin.
Hi, it's great to be here. I'm a big fan.
And I'm here with Liam Randall of Cosmonic. Thanks for joining us, Liam.
Thanks for having us on today, big fan.
And I was wondering if you could please describe for the folks who have very likely heard of Wasm, or WebAssembly, Wasm, and describe what it is and what can it do in ways that they might not necessarily know about yet, even though they've heard about it. That's one of the major CNCF projects and one of the major topics at this conference.
Yeah, let's start with what is WebAssembly. And WebAssembly is a big deal because it's only the fourth language officially approved by the W3C for the web. So that means that this is an open standard, this is a community-driven standard, and it means that it's something that everybody can reliably build and depend on, much like HTML, CSS, or JavaScript. So WebAssembly came out of the Skunkworks engine that is Mozilla Firefox, and the team has standardized this component and made it approachable and accessible for everybody. So WebAssembly is one of those technologies that you don't need a strategy to adopt because great companies like Adobe and Microsoft and Cosmonic are bringing solutions to the market today that everybody's already using.
When you said anybody can adopt it, you're talking about on the CPU level, right?
That's right. WebAssembly, if we want to think about it, what does it mean logically? It gives you a promise that you've probably heard before, write once, run anywhere. And you've heard that before with maybe Java or Silverlight or Flash or one of the previous technologies. The difference with WebAssembly is that this is community-driven and open, and it's already embedded and supported in all of the modern browser platforms on desktop and mobile devices today. So everybody can start using WebAssembly, which functionally works like a little tiny CPU. You can even put WebAssembly inside of other applications. So it's being adopted as a way to customize applications in a safe and secure way. It gives you a secure sandbox that's very fast and very performant. Now, it's an emerging technology, so it doesn't support every programming language, but it is essentially polyglot. So you can bring code from Python, for example, or from Rust, or from C or C++ right into the browser, or even onto server-side technologies as well.
Because before, people were associating it with Rust, for example, I'm assuming, and other more mobile applications. But this is not that, and it's not exactly a compiler. It's not exactly a language. What is it?
It's a compilation target.
Yeah.
It's a runtime. Yeah.
And so, what are the specific use cases? What can we do with it? And you at the Wasm Days talks, which I enjoyed, particularly your presentation, you're doing something with Adobe.
Right, so I'm not doing anything related to, it's other people at Adobe, so just want to be super clear. But it's, so we have at Adobe, we have a lot of C++ code, that's a lot of great code, like with great products people want, and what WebAssembly allows you to do is bring that code into the browser. And so we wouldn't have been able to bring Photoshop and Lightroom and Acrobat to the browser without it. So, and there's been a lot of great work done. You can read about it. The Chrome team has a great article up.
Where? Which publication or which outlet?
It's the Chrome blog. It's the Chrome dev blog.
Okay, I'll check that out.
And there's just a fantastic article with some really bright people and Adobe, and just based off of that, Adobe's done a lot of work to improve the WebAssembly standard. for higher performance and better fast memory access, things like that.
Yeah, so, sorry, go ahead.
The one thing I would want to build on after that, though, is that while WebAssembly, much like JavaScript before it was originally designed for web browsers, WebAssembly as a technology transcends the web browser itself. In fact, in many ways, it breaks down the walls, this artificial wall between things that we would think of as running on the front side or the back side. Because what WebAssembly really is, it's now a universally portable and ubiquitous execution platform that has a consistent security model that operates edge to edge. So the same code that you want to build and run on servers can now be taken inside of web browsers or even into embedded or smaller devices down the hill. So while some of the early amazing experiences are similar to the things that Colin is mentioning that Adobe has been pioneering and leading, some of the next great uses for use cases for WebAssembly are embedding into other applications such as into Envoy. There's a great company, Solo.io. They've got a few blog posts about the great work that they've been doing. There are whole applications like KubeArmor that embed WebAssembly as essentially a customization engine. And what Cosmonic works on is the open source project CNCF Wasm Cloud, which is a framework that helps you to use WebAssembly faster on things like servers and microservices. So you now can write things that can transcend not just different CPUs, but different clouds, edges, and browsers as well.
Yeah, I'd like to touch upon that in depth, but I'd like to interject one thing that just came into my mind when you were saying this, is that maybe WebAssembly is not the right nomenclature. I mean, you're associating it with web and mobile apps and JavaScript, et cetera. Maybe it's a time for a name change.
Well, it's hard because WebAssembly is neither web nor assembly. It's a race to make the joke, right?
Yeah, it's
neither web nor assembly. So somewhat awkwardly named technology, but a technology that is worth looking into because whether you design a strategy for it or not, your organization is already using, adopting, and scaling WebAssembly, and there are incredible opportunities for your internal teams to transform the way they do business, to save costs, and be more secure by adopting this new standard for the web.
And what you were saying, Colin, was interesting because when I saw your presentation, I thought, oh, Adobe's using Wasm to have fun, do a sandbox project. It's something fun to do as a sandbox project. So, but no, it is solving an important business need.
Right. Well, so there's a big distinction to be made. So there's that WebAssembly that's written for the browser. And there's a lot, that's a fully mature, obviously, product. And then we have the WASI standard, WebAssembly System Interface standard, and that's what's behind Fastly's Computed Edge, and that's related to what Liam's team is doing, and a lot of other teams are doing. So that is still kind of up and coming. In a lot of ways, and it's much more limited at this time than what you can do in the browser. And so that's where I kind of came into it from a server side perspective. Back when I was within Document Cloud, was there were a lot of problems that Docker had. Now Docker's obviously great. We've done great things with Docker, but in certain circumstances, there's something really compelling about server-side Wasm or at-edge Wasm, and it started for me with vulnerabilities with our FedRAMP Adobe Sign product, where we had to all of a sudden start tracking every CVE, and we would be using lots of third-party images, and they would come with different vulnerabilities, and sometimes the same vulnerability would have multiple CVEs.
In the container. On a container
yeah,
level.
with Docker containers, sorry.
Yeah.
And so, with a WebAssembly, you don't have any of that third-party stuff. It's just really you can think of it just like a binary. Now, of course, you'd still have a chain, right? You're still using libraries, and of course, there'll always be security concerns. But yeah, that idea of you don't have to bring all the rest of an operating system. You don't have to pretend it's an operating system. It's really its own unit.
You mentioned that in your talk, which I tweeted.
You tweeted?
Yeah.
Okay, good. I'm not on Twitter.
That we're replacing Docker. Is that important?
Well, so
and why? Why not?
Oh no, what did I say?
It was written. It was in the PowerPoint presentation.
Okay, so there are places, right? Wait, be careful. There are places where it will replace Docker.
Okay.
It's not, just like we still have, there are still mainframes, there are still host OSs, there are still VMs that have very particular business cases and will continue to be used. But there are some really nice places, particularly on the edge, in 5G, in cars, in all these kinds of, where IoT meets everything meets the world and meets edge, where you're not going to be able to bring Docker with you, and then on the other hand, it's also can be very efficient. And there's a lot. It's really stripped down, and so it can, for really high compute, high throughput use cases, be incredibly effective.
Is Elon Musk listening to this?
I think we really have two different topics here that are on the table at the time. There is WebAssembly, which is essentially like a virtual CPU. There's Wasm, which is like virtual POSIX extensions that will give you a place to start and build on if you're building inside of WebAssembly. But if we want to talk a little bit about the comparison between Docker, which is a method for packaging up applications at the operating system level, sitting on top of libc, and WebAssembly, it's not really fair to do a direct comparison between the two because they have different design goals, they do different things. And in some ways, I would really want to double down and say that these technologies really are better together. That while there are places, there are times when you would want to use Docker because you've already lifted and shifted your application there, you already have this embedded CI/CD system that's built around it, you can get started with WebAssembly by simply running it inside of Docker. These technologies are compatible with each other. But let's talk about what Colin's greater point here was that Docker as an abstraction does bring with it a couple of fundamental assumptions that sort of force a lower bound as to where you can take Docker. When you're thinking about Docker, you sort of are already agreeing to two commitments. You're saying, I know what my CPU architecture is that I'm going to be running on, like x86 or ARM, and that I'm going to be running on something Linux-centric. So my security model is then inherited from Linux. So when you think about that, that will have a really low lower bound. You can take Kubernetes out towards the edges. But two of the most popular places where we want to run our workloads today don't run Linux and don't even have a concept of a processor, never mind a security model that's based on Linux. So think about iOS, for example, not Linux.
Right.
Think about web browsers, for example, not Linux and doesn't have CPUs. So I think that when we think about how this fits into the landscape, WebAssembly really is exciting because it gives us two fundamental things that are truly amazing. One is portability across a diverse set of CPUs and architectures, and even portability into other places like into a web browser. It also gives us a security model that's portable and works the same across all of those different landscape settings. So for example, WebAssembly is reactive and deny by default, and it's this thing called capability driven. So if you want to give WebAssembly permissions to do something, you have to explicitly grant and give it that permission model. Now that permission model is very simple, but that simplicity makes it so that it can work inside of a Docker container, it can work on bare metal, it can work on OpenStack, it can work inside of a web browser, an embedded device, inside your automobile, and everything else. So WebAssembly gives us this possibility of transcending the lower bound of Kubernetes and Docker as a application virtualization technology.
And in order to aid that, or another layer that's often required, it just makes life so much easier, can we say that, is Wasm Cloud. And how does that work?
Yeah, thank you. And so when you think about how we use the other four languages for the web, let's take HTML, for example. If you were going to build a new user interface today, you would very unlikely start with a blank notepad. You would probably start with an existing framework, something like React, something that sort of gets you going and gets you helping. Now, as cool as WebAssembly is, it's a very low-level technology. It's just numbers in and numbers out. It's a small RISC-type CPU that's very fast, very efficient by design.
It's like HTML, maybe. Can we say that?
It's
in the early days.
It's as simple as HTML in the early days.
Yeah.
But what we created originally when we were out of Capital One is a framework for using WebAssembly to get you started and moving faster. And we donated this to the CNCF last year. It's called Wasm Cloud. And since we put Wasm Cloud into the CNCF, we've absolutely blown up. We've got incredible contributors and participants from all over the cloud native landscape. Adobe mentioned that they're using it. BMW did a talk this week about not only they partnered with Intel to create machine learning extensions for Wasm Cloud, but what this framework does is it solves some of the underlying complexities of using WebAssembly and lets your developers just write business logic that's portable and matters. So Wasm Cloud does for WebAssembly what React does for HTML. And the developer experience is designed to really deliver the sort of uplift that Docker gave to containers.
This came into my head, but maybe we need a WordPress type of analogy on top of that eventually, or not.
Yeah, well, if you did you see Matt Butcher's talk?
No.
Matt Bircher, the founder and CEO of Fermyon.
Yeah.
They started with a
CMS.
CMS.
Yeah.
Yeah. That was
I did
the first
see that.
product. Like,
I did see that.
They held
yeah,
off
you're
on
right.
announcing
No,
the company
forgive me,
waiting
yeah.
for a month or whatever to get
Yeah,
the CMS.
yeah, they didn't have a website.
Yeah,
Right,
for a while,
you know,
yeah.
there's when we think about WebAssembly, there are so many different wonderful use cases. There's actually a whole emerging ecosystem of startups and projects that have been incubated in and around the CNCF. Colin mentioned Fermyon, Matt Butcher's company, which is the DS Labs team out of Microsoft. There's also another one, Suborbital. They've got a project that's designed around embedding logic into other applications called Atmo. There's a new one that just spun up called Mycelial. And there are even a bunch of closed proprietary ones. Some of the edge products from people like Fastly and Cloudflare are very WebAssembly centric underneath the hood. So I think that at this point, for those of us that are frequent early adopters, you know, I launched one of the first Kubernetes companies. It's clear to me that WebAssembly is not only here to stay, but it has won the war and is the de facto standard for moving forward in this ubiquitous universal runtime.
Excellent. Oh, Colin, go ahead.
Oh yeah, well, just to wrap up, there's really two big areas I see going forward, and kind of just in addition to what Liam's saying. One is inference at the edge, so machine learning inference at the edge, or in distributed, in many different locations, and the other is collaboration.
Okay.
So collaborative experiences really can be is what WebAssembly is really perfectly positioned for.
Excellent. It's B. Cameron Gain, correspondent with the New Stack. It's been really fascinating on my end with Colin Murphy from Adobe and Liam Randall from Cosmonic. Thank you very much for joining us.
Thanks for having us.
If you like this video, please give us a thumbs up. And if you'd like to see more videos like this, you can always subscribe to our YouTube channel. We're on all the major social media platforms. You can always find us at thenewstack.io. We hope to see you soon.